Hi, everybody. This is a recording for the summary of the lesson from today, Tuesday, October 10th. A couple announcements really quickly before we started class. I want to make sure that I graded your flashcards. So some of you guys have been gone a couple days, and I just want to remind you when I get back, please make sure that you show me your flashcards because that is a completion grade, whether you are done or not. Make sure that you show me what you have done, and I'll just give you a percentage of what you're supposed to have. If you are also gone, you may not have received your scientific argument back. And I've asked a few of the kids to please revise those. And so if you are one of those people, when you come back, I want to make sure that I work with you for revision. And then the last thing I want to let you know is that I have to be gone Thursday and Friday. I'm on a committee for school. And we have a conference in Kearney those days. So I'll be gone on Thursday and Friday. If for some reason you are sick and you're gone and then you come back and I'm gone, just jump in with the class where you're at. And then you and I will figure out what's going on with you individually as soon as I get back on Monday. All right? We'll just figure it out. It'll be okay. Today we discussed the ancient Mesosaurus article. So again, if you were absent yesterday, that was an article that is in yesterday's folder. You should annotate that, read it, and annotate it. And then we also are working still to finish Plate Motion 1.2. So let's go ahead and get started. This is our article about Mesosaurus. We just took about 10 minutes at the beginning of class. Kids made observations about what they discovered. A couple of things really quickly. We want to talk about some theories or some ideas that people have, some hypotheses that people had about Mesosaurus. As you read through this, it's important to find out what kind of an animal it is. We know based on the descriptions that it had nostrils on top of the nose, and that's indicative of an organism that is that's able to stay underwater but breathes, like they can just put their snout up above. Some kids were talking about it reminds them of dolphins in the blowhole, how would they come to the surface and they're able to stay under surface, but they have lungs, and so they have to have that gas exchange. And then also in this, it talks about how they had webbed feet. And we just talked about what kind of evidence scientists can get from fossils, how they use the evidence from fossils and base that on information that they have about organisms that are alive today. They make comparisons, they're able to draw conclusions. We also talked about maybe the idea that the reason why these Mesosaurus fossils were found on two different continents was because maybe they swam from one to the other. But there are actually two places in the article, in the actual paragraph, and then underneath this photo here that says they did live in the water, but there's no way they could have swam across an entire ocean. There's one space right in the middle. It is, no, I guess it's a little bit up at the top. How many lines is that? 1, 2, 3. Look at the fourth line. It says they had webbed feet and grew up to about 1 meter, 3.3 feet long. The picture here shows this image of a lizard, and to us it looks like maybe the Loch Ness Monster. It looks huge, but in reality they were from tip to tail to tip to nose only 1 meter long. Think of my meter stick at school. Up at the beginning here in the third line, it said that they look a bit like a small crocodile. So just maintaining this idea of how big Mesosaurus is, I think, is important for us. So when you think about an organism that small swimming across an entire ocean, it was not able to do that. It needed land. It would tire out, and then it wouldn't be able to. It would drown, basically. And then we talked about the idea of maybe a predator. Like, we make observations now and we see birds of prey, like an eagle, picking up a lizard and carrying it off. And so then we thought, well, can we talk about that? Do you think that's a possibility? And the idea that a bird of prey would pick up a lizard like this and then fly across an entire ocean before it ate it kind of seemed far-fetched. We don't see any behavior like that. We don't see birds of prey carrying long distance. The birds of prey would get tired. It just doesn't match with what we know how those organisms behave. Even if this was a long time ago and the predators of these organisms may be different than what they are now, it's just kind of far-fetched. So then we were looking at the picture down below, and you can't help but notice South America looks like if you could just slide it somehow close to Africa, that little notch in South America would fit the little cutout part in Africa. And so what we did is we just traced along the coast of South America and then traced along the coast of Africa just with a red pen. And then we drew arrows that pointed towards each other and then put a question mark. And we're just trying to say, is that possible? Do we think maybe at one point in time this was one land? And the interesting thing is, if we would do that, then look what happens to the green circle that's highlighted right there too. And so then the idea that Mesosaurus lived in one place at one time totally makes sense. So then it's like, okay, then how did it become separated the way that it is? So anyway, we just had some really good discussion. Didn't really talk about answers as much as just kind of making observations, which is what scientists do all the time when they first begin an investigation. So that's exactly what we did. I want to see that you have your article annotated. So that is a grade that I'm going to expect you to show me as soon as you come back. Make sure that that's finished. Okay? All right, so then we are in activity number 3 with lesson 2.1. We reminded each other that we were talking about the geosphere, which is part of the Earth system. And our investigation question today is, what is the Earth's outer layer like underneath Earth's surface? We talked about how scientists find out what's underneath the surface of the Earth by drilling. So they'll drill down, and they can drill land drilling, they drill off of ships, they drill through ice, and they're able to get what's called a core sample. And the core sample, they split in half then, and that becomes a cross-section. And a cross-section is a diagram that shows what the inside of something looks like. So think back to your beginning of the unit test. Remember the picture of the apple, the diagram of the apple? The the cross section is the picture of the apple that's been cut in half so that you can see the inside of that apple. So here's a picture of some real core samples. We believe that the markings there are indicative of how many meters below surface they were. And then what happens is the scientists will take a saw that's covered with a diamond tip, and they cut those in half. And then you open them up, and this is what you see, something like this. Now, you would never know based on the outside what's on the inside. And so scientists are able to look at these, and you can see we've got different layers. Like, just take a second to look at the very first sample there on the left. Do you see the lines? It looks like layers of things, and that's exactly what it is. It's rock layers. So this is sedimentary rock. It's been laid down. It's taken thousands and thousands and thousands of years for that rock to go through cementation and sedimentation and cementation for it to turn into rock. And it's just interesting how you would not ever be able to see these striations or the layers just by looking at the outside of the rock. So that's why scientists do it. They want to see what's underneath the surface of the Earth. So if you go into activity number 3, across the bottom, there are, I believe, 6 circles. Go ahead and click on the second circle. We've got 4 different examples of how scientists can use cross sections to find out what's below the surface of the Earth. So the first one takes place in Arizona, and I can let you read that, but I'm just going to go through real quick and summarize what we learned. So they started out with this core sample, and for the first 17 meters, what they got was rock that was formed during volcanic eruptions. And then underneath that, for the next hundreds of meters, was hard solid rock formed from sediment. Now these are going to look different. Like in this picture, the sedimentary rock is layered. Now the igneous rock is going to be like basalt, where there is no layering, it's just the solid black all the way through. So they're able to identify what kind of rock it is, and they're also able to see where one starts and one ends. But the bottom line is, underneath all of the vegetation, underneath everything, Earth's outer layer, the crust, the geosphere, is made of hard solid rock. So let's go to a different location. Let's go to Hawaii. So they're on top of a volcano and they just drill straight through that volcano, right? So they're looking, and it is 100% solid rock formed during volcanic eruptions. This is called igneous rock. And again, look at the cross sections, or I'm sorry, the core samples, the cross section of the core samples. They've cut those in half, and you can see that those are made of hard solid rock. And I want you to go ahead and look at the next two, because the bell just rang. I've got a class coming in. I want to get going. You're going to see that Earth's outer layer is made of hard solid rock. And in fact, that's our key concept, the very first one. Earth's outer layer is made of hard solid rock. So your homework is inside this folder. There's this model. I want you to follow the directions, shade the regions where Earth's outer layer is made of hard solid rock, and then go ahead and hand that in to me. All right, I'll see you later.